Okay, let's see if this works. So I'm going to set up a couple of these for you and see where you can get. It says water is flowing at a rate of 50 cubic meters per minute from a concrete conical reservoir. So that's a cone, right? The radius is 45 meters. The height is 6 meters. Use this information to complete the exercises. So it says, how fast is the water level falling when the water is 5 feet deep? So the water level, that would be like the volume again, just like the other ones, right? So that would be volume equals 1/3 pi r squared h. So this is just like the other one that we set up. I feel like I'm missing. Oh, there we go. Water is flowing at a rate of 50 cubic meters per minute from a concrete reservoir. So that would mean that they're giving us dV over dt. But since it's flowing from it, that means it's coming out of it, right? So that would be negative 50 cubic feet per minute. And just like the other one that we did, the R value needs to be substituted in. So you have to use this information that R over H equals 45 over 6 to set up that problem. Just like the one I set up for you in class today. And then you'll have to substitute it in and you'll get H cubed again and probably an ugly decimal. So hopefully maybe you could set that one up a little bit further now. And then you have to do 16 in order to be able to look at 17. But again, how fast is the surface area of the water changing? How fast is the radius of the water surface? So the radius of the water surface is not surface area. The water surface is just a circle, right? So you're just going to use pi r squared, right? Where's this coming from? Oh my goodness. I should be better prepared, right? Two over 45. All right, we'll look at that one in class. This is the one I really want you to talk about, okay? You probably gave up on me already. This is the one I was talking about that was similar to one that I saw on a AP test once. And so it says, a man 6 feet tall is walking toward the street light. So here's the guy. Oh man, he's really tall. Here's my street light. That's a good street light, right? And so they tell me that he's 6 feet tall and the street light is 16 feet tall. And he's walking towards this, right? So this would be a rate. At what rate is the length of his shadow? So his shadow would be like down here on the ground, right? And so you could write like, I don't know, I always struggle with this. I always want to draw the line here, but I think I have to draw it to the shadow, right? I want to change colors here and make this be like from here to the shadow. So two things are happening. As he's going towards the street light, this distance is changing, but his shadow is also changing, right? So I feel like we need two variables, like an X and a Y, or I think I like to use shadow here. So I like to use S for shadow to help me keep it straight. Also, I like to use a color to keep it straight. What does that mean for this problem is that we kind of end up setting up similar triangles where like this is one triangle here and then the big triangle is the other triangle. And to me that was really hard the first time I did that. So what does that mean? Well, I could definitely set up like 16 over 6, this height compared to this height. So the big height compared to this height over the other side that I know is this length, and on the big triangle that would be X plus S, and on the little triangle that would just be S. Do you agree with that? And so then I could solve it. I could say 16S equals 6X plus 6S. And I could even subtract 6x over to say 10s equals 6x. And then when you take the derivative of that, you get 10 ds over dt equals 6 dx over dt. And I could have divided that out as well. But to me, the hard part of that is setting that problem up. And then now you can just plug in the values. He's walking at a rate of 5 feet per second. So is that dx over dt or ds over dt? That's this, right? So he's walking towards the street light. So should that be negative or positive? This distance is getting smaller, so that would be negative 5. So ds over dt would equal negative 30 over 10, or ds over dt would equal negative 3 feet per second. Okay, stay away from him. Okay, I like that one, but the first time I did it, I really didn't like it. Okay. All right. I'm just struggling on 17 right now, so I'm not going to do that one. These last ones again are ones that are similar to ones I've seen before. It says the volume of a cube is increasing at a rate of 24 inches cubed per minute, and each edge is increasing at 2 inches per minute. What is the length of each side of the cube? Well, a cube would be length times width times height is the same. So the volume of a cube is like side cubed. So then what would that be? dv over dt equals 3 side squared ds over dt. And since they give you this rate, which is your volume, and they give you this rate, which is this, you could solve for the side now, right? What about number 20? They give you the volume and they give you the surface area. So I think this one you have to do a little bit more work. So I'm not going to do all this for you, but the volume of a cube is side cubed, and the surface area of a cube, do you know that one? Surface area is if you take the area of each side, which is side squared, and then there's 6 sides, so I believe that that is 6 sides squared. And then I think you might have to do some work on that. Okay? And then I want you to see where you can get on 21, see if you can draw a picture, and we will see if we can work on those in class. Okay?